In this video, we're going to be going over the chain rule, and this is a calculus topic, which says that if we have a function of within a function, so in this example, it just says placeholder functions, we have f of g of x. Then if we want to find the derivative of the overall function, then we take the derivative of the outside, keep the inside, and then multiply it by g prime of x. And you can see some examples here that we're going to go through. It looks just like this. Now you're like, why is it called the chain rule? Well, it doesn't just apply to, this can be very deceiving, right? It could be f of g of j of f of d of x, and that would be 1, 2, 3, 4, 5. If we have some extremely long function, we can use the chain rule. We can take all of the derivatives here and get an overall function derivative. So that's why we call it the chain rule. Now you won't see any chains. You'll probably in a normal calculus course only see up to a function on the outside of another function on the inside, and it's only to one chain. So I have some examples here that I want to get through. This might be a little confusing here, right? Because we're going from u and v to function values. And you're going to see that the exponent here, that's the outer function. 7 is f in this example. This is f, and this is g of x, right? That's the components. And it looks a little weird. Okay, you're not used to f, a function value, being an exponent. But in this case it is. So we have f and g of x here. We defined it as such. So I'm going to go ahead and erase that just to keep things tidy. So let's now take the derivative, right? So what's the derivative of f of 1? Well, bring the exponent down, subtract by 1. So we're going to see that we're going to have 7. We're going to keep the inside the same. And we're going to have that. So you can kind of see, right? Imagine this is like a variable x to the 7. How do you take the derivative of that? Bring the exponent down, 7x to the 6th, right? So treat the inside function as a separate thing, as just being there, right? And as you would expect, that's what this kind of looks like. That's what I want you to think in your mind as you're going through these kind of problems. But we're not done yet. We need to now take the derivative of the inside. So we're going to take the derivative of this piece, right? The 6x minus 5. So we know that a constant will drop out, so we don't have to worry about that. But the 6x here, that's just going to be plus 6. Okay, pretty simple. It's not plus 6, it's multiplied by 6. Because I was about to say we need to make a simplification here. You can see that we have 7 times 6. We're allowed to multiply it over. So we'll write this as 42 times 6x minus 5 of 6 is equal to the derivative here. So there you go. That's the derivative of the function. All right, let's move on to number 2 here. This one is just a checkpoint to make sure that you understand that we can write this in a different way, right? It's a cube root, but we can also express it like this, to the 1/3 power. This is one of the most humongous things that if you are going to take into coming into calculus, is that you know that you can express square roots, cube roots, and so on, nth roots, as fractional exponents. You need to know that. And in this case, we have it written out as such. So, and here's why it's important, because now we can do the chain rule. Now that it's in this simplified, nice little form, we can bring the exponent out front, 2x to the 3rd plus 2x to the negative 2/3. Okay? So we did the first part of the chain rule, this section here. Now we need to do the g prime of x, which is the inside of the function. So we simply are just going to multiply by, and we take the derivative of this and this respectively. So we're going to get 6x squared plus 2. Okay? We can distribute the 1/3 into our other part here. So 2x to the 3rd plus 2x to the negative 2/3 power. And 1/3 times 6 is 2. And I need a calculator for the other one, so my apologies. 2 times 1/3 is 2/3. I should know that. That's not good that I don't know that. Whatever. Now, if we want to even go ahead and make this look even prettier, let's see, I have prime of x here. Okay. So if we want to make this look a little prettier, and I'll just cut that portion off. If we want to make this look prettier, we can actually bring this to the denominator. So we can say that 2x squared plus 2/3 is equal to, and remember, if it's a negative exponent, we can bring it to the denominator, right? Because you flip the sign of your exponent when you move from the denominator to the numerator and vice versa. So we can actually write this as 2x to the third plus 2x in parentheses to the 2/3. So that's the simplified, looks nice version of our function, and that is the derivative. So for this last problem here, we have 3x over 5x plus 3 squared. Now, these problems can be quite tricky. It's a quotient rule and a chain rule, and we'll see why it's a quotient and a chain rule. But notice that it's a fraction, and then at the bottom we have a function squared. So let's actually just define our variables using what we learned last video. We know that u is 3x, and that means u prime is 3. V we said is 5x plus 3 squared, and let me define that v a little better. I feel like whoever designed the UV system is just trying to mess with us a little bit. He's like, hey, let's take the 2 letters that look the most similar in the alphabet. That would be good for undergraduates, right? And then v prime of x is a chain rule, so we have to take this as 2 5x plus 3, and then this is times 5. So because we're taking the inside derivative, and then we're actually going to bring it out front to make it 10. So 2 times 5, that's 10. Okay, so we're ready to set up our, I could even write that out, but we're actually going to keep it simplified here. Try and keep things not too drawn out, because there's some simplification techniques, which we'll see. So we know that it's 5x plus 3 squared, and I'm setting up a quotient rule, by the way. We know it's v u prime minus v prime u. So that there times 3 minus, and this will be minus, oh geez, I'm brain farting. Yep, we're good. 10 5x plus 3, and then 3x. And this is all over v squared, which is 5x plus 3 to the 4th, right? Because if we have 2 to the 2 to the 2, that's 2 times 2, that's 4. Remember, your exponent rule is very important. Okay, so now let's make some simplifications here. I notice that there are 2 terms on the top. Okay, do they have a common factor? You would say yes. There's a 5x plus 3 here. There's a 5x plus 3 there. So what we can do is actually bring it out front of the entire expression on the top. So it would look something like this. And I know this might look a little strange to some people, and fair. I think it's a little strange too, but it's a wonderful way. And I'm actually going to simplify our inner terms so we don't have to make a simplification step. 10 times 3x is 30x. We're allowed to do that. We took out the 5x there, so that's just gone. And then here I'll also make a simplification. 3 times 5, 3 times 3. So that's going to be 15x plus 9. 15x plus 9. So here's our expression, a little more simplified, but we can actually take it one step further. In division, if I asked you, for example, xy over x to the 4th, how could you simplify this? Well, we know that we're allowed to cancel the x on the top to leave us with y to the x to the third. And it's the exact same here. Imagine that this section's y and this section's x, and this is x to the fourth. Well, notice it's the same kind of spiel, just a little more complicated, right, than we're used to. So we are actually allowed to cancel out one of these here, right? So in total, we're going to get, and I'm going to simplify this here as well. This is going to be negative 15x plus 9, right? 15x minus 30 plus 9. And we're going to be left with 5x plus 3 to the third on top. Alrighty, are we allowed to do any more simplification? We are not, because, right, okay. So this is our final derivative value, negative 15x plus 9 over 5x plus 3 to the third. That's the derivative of a quotient here. Gets kind of messy, and you'll have problems where you'll probably spend half a page writing stuff out, writing out simplifications. Try and make it a little easier on yourself. See if there's any ways so you don't have to write out big, crazy long pages of work, because your calculus teacher will try and torture you like that, I promise you. I hope you guys enjoyed this video. Come to our next video where we talk about derivatives with trig.